Welcome to the AW Services YouTube channel. In this video, it's a bit of an electronics themed video. It might appeal to a few of my followers out there, but here goes. As I've mentioned in a previous video, this is my Bescor is the brand, also Hague and CamRanger. So Hague, CamRanger and Bescor PH, which is a pan tilt head. It's battery operated. 6 volts, runs on 4 AA batteries. It can also run on a mains adapter, and the objective of this is it sits on top of a tripod, and with a remote control that's wired, you can go up and down, left and right, so you can pan and tilt the head, and it rotates as well. It's brilliant for video production, live streaming, whether you're a blogger. And one of the reasons that these were invented, this is what I believe, before drones came onto the market in about 2010, accessible camera platforms in the sky being drones, before that a lot of people used to use these for various filming activities, commonly used in sports training and grassroots football, where you can get a 20, 30, 40 foot really high quality heavy duty tripod, put this 20 to 30 feet up in the air with a DSLR camera or a camcorder at that time on top of it, and with a remote control you could pan it around, tilt it, and you were able to film football matches, hockey matches, etc. But it doesn't give you the zoom facility. So unless you've got a means of previewing a camera, like nowadays with GoPros, you can live view them on your phone, etc., so you can get a live transmitted video image of what you're seeing POV. It's useful, but they were designed for that. But I've used these for many occasions for live music events, DJ events, etc., where I've been a photographer for an event, whether it's a Dave Pearce night, lots of other famous DJs I've worked along with, like Sonic, James Hype even, and I've had this on a tripod beside where the DJ is set up, and instead of me getting in the way and blocking the view to the public that are paying to see that act, I can then have this automatically move around with the remote control with a GoPro on top, and I can record hours of video footage and then change the angle of it, where it's panning, where it's tilting, and then edit all that together, which will seamlessly appear to be that I've had a camera, but I've not obscured the view, so to speak. But it's a brilliant piece of kit, brand new. They're about £230 in the UK. You can get them in America as well. Bescor, CamRanger, you might be familiar with to my American audience over there. You can also have the wired remote control, which comes with this as standard when you purchase it brand new. I bought this one in immaculate new condition, new old stock in a box from a gentleman on eBay, and I paid £25 for it, and I got an absolute bargain because there's not a scratch on it, and it was new in the box. But the only thing was the gentleman had lost the wired remote control for it, so it was sold untested without a remote control. So I took a chance, but with electronics, it's just got a standard old school 7-pin DIN plug in there, and you've got 5 volts, speed control, up, down, left and right controls. So it didn't take long for me to reverse engineer that socket by wiring jumper wires into there and testing its functionality so it works. And you can have it set to 45 degrees, 340 degrees. Mine is a 340 degree unit, so there are others, I think, that are only 90 degrees. So I've got the wired remote control for it, and I made my own remote control with a longer cable. But I thought I can go wireless with this, being that it's old analog and it just needs a 5 volt. So it's got a 5 volt supply in there. It just means a way of connecting that together. It could have been done via a relay, but I'm going to do this with a wireless modification. So like I've said previously, if you're into video production, blogging, live streaming, you've got a YouTube channel where you do reviews on products, and you have this on a tripod, but you could then set that in front of you, but then off camera with your hand, you could actually move the camera, whether you're doing a podcast of 4 people, etc. It'd be brilliant for that. So that is it. That is the PH pan tilt head from Hague, Bescor and CamRanger. So what we're going to do in this video is I'll talk you through the craziness. So what we have is our pan tilt head. I've got a very generic wireless remote control module, which I purchased from eBay. The gentleman that sold this to me was actually probably one of the second quickest eBay parcels I've ever had. It wasn't someone that messed around with second class post. It was first class. It was well packaged and it came to me extremely quickly. So a generic remote control in a beautiful Chinesium style wood grain effect. Buttons A, buttons B, buttons C, buttons D. So it's a 4-channel wireless remote control with a pull-out aerial on there. Never really use these aerials. They're either going to snap off, but you'll get 20-30 meter range out of this anyway without the aerial. So this particular one is 315 megahertz. You can also get 315 or you can get 344 megahertz. It comes with a wireless receiver module which accompanies the remote control. So it's extremely small, matchbox size. So what I will say, I'll just get something to give you a bit of contrast on the remote control. So on the Jiffy packet is the remote control receiver module. Not very big at all. So length of that is 1.5 inches by 1 inch, or 25 millimeters by about 41 millimeters. This one here didn't come with an antenna affixed to it. So what I've done, where the actual solder pad is on the circuit board, unfortunately GoPros don't focus or zoom their fixed objective. So on the bottom here where the pencil tip is, there's a solder pad saying ANT for antenna. So all I've done is I've got some, I did have some copper wire, but I've lost the copper wire that I had. So all I did is went to my local retailer, BJ's Value House here in Barnstaple, Devon, an incredible family-owned business that sells hardware. It sells everything. And I bought some coated 1.5 millimeter steel garden wire. I cut the wire to length. So I've got a bit of a background with amateur radio, etc., building transmitters, receivers, radios, and I've got a very good understanding of aerials and antennas. So an antenna is something which will also send and receive from, and this is an aerial because it will only receive. So I've used a basic antenna aerial calculator. I've typed in 315 megahertz, and it's given me a predefined overall wire length of 23.8 centimeters or 238 millimeters. I've made sure that there's no sheathing that's loose, so I've cut that piece of wire, the whole length of that wire, to 238 millimeters. I then got a very thin piece of steel rod. I taped one end of that to the end of the steel rod, put it in my battery drill and just used it as a mandrel and wound it to coil it to make myself a nice size antenna, or an aerial, sorry. So on the board we have 8 pins. I'm only going to be using 7 pins. So I've got 5 volts, I've got ground, and then I've got up, down, left and right. So the header pins on here, you can also use IGE header pin kit where you've got your male and your female connectors, and you've got your standard header pins where you've got a double rows of 6, you've got singles, you've got triples, quads, and they're basically header pin connectors. And you can crimp these up, which you'd see in most circuit board configurations, Molex, and you can put them on. I'm not using these because I find in portable non-static applications they vibrate and they can fall off. So all I'm going to do is tin the contacts on the pins and solder directly to those. So that's the transmitter and receiver. Did some quick measuring on this before I even purchased it. I went onto Amazon and I purchased a packet of 3 enclosures, ABS boxes in English. Very small, very compact, extremely affordable, but they're just the size that I want. And once I've got my electronics inside, I will put some stiff Velcro hook and loop on that side, a piece of soft Velcro hook and loop on that side, and I can just Velcro that to the side of the pan tilt head with a short cable with a 7-tin plug, and that's all I need to have a fully capable remote control kit. So I measured my enclosure exactly the size, so just to give you an idea, that's the lid of it, that's the size of the actual receiver, and it fits perfectly within that and gives me some space for my wiring. So that will sit nice and snug and square on the inside of my enclosure like so. I drill a hole. I will put a rubber strain relief kind of grommet. It isn't a gland, it's just a grommet through there with some hot glue and a cable tie to stop that pulling out. Another one of my favourite tips for anyone that's wanting to get into electronics, and if you're going to make circuit boards etc and use boxes like this, the best thing to do is to get yourself some high quality masking tape. Don't buy cheap, the ultimate cheapest stuff you can find, because it doesn't work and it rips very easily. You can never get it off the roll. But this is Super Deck, very good quality masking tape here in the UK, or you can use like a brown parcel tape wherever you are in the world. Tear some of that off, and I always recommend, like a lot of people used to say with mathematics, show you working out first. So get some of this. I've measured it and put it onto the end of my enclosure. I've marked a cross on there end to end, which will give me my center position. I'll pilot drill that and then drill that out to the correct size of that. But like in many of my videos when I'm doing electronics, I'm using masking tape as a substrate to mark out things, because on a black box you can mark on that with a pencil if you wish to do so, but it's just going to show up. So like I've done with my various videos, which I'll put a link up here in the top right hand corner on my water fed pole pump trolley etc for window cleaning, I used an awful lot of masking tape on my larger enclosure box, because I can measure and mark out and determine where my drilling points are, where I might put switches, where I might put LEDs. But the whole reason for that is to give you a clean and professional like finish, where you've not got scratches all over where you're working, and you haven't got pencil marks and Sharpie marks on there. And once all your holes and positions are drilled as per your plan, you can peel the tape off and you're left with a beautifully clean enclosure that's not got scratches. So there's a little tip for you if you're into electronics. So what we're going to do now is I am going to drill the box, and I'm going to put the rubber gland in. These are on Amazon. They're very soft rubber. They're 5.5 millimeters. I haven't got an affiliate link. I did try to set it up, but I haven't got time for it. Really not interested in earning any more money. But what I'll do, I'll post all the links to everything that I'm using in this video, which you can find down in the description. And then you can get links and go directly to where these bits are purchased from. And I will provide also on screen at some point when I edit the video a circuit diagram, and to show you exactly what I'm building and how you can go about doing it if you wish to emulate and copy my project. But it isn't a how-to, it's what I'm doing. So this is what I'm doing, but I thought I'd share it with a wider community of people, because knowledge is power. I'm not someone that's selfish. I'm not going to go, oh, that's my idea, I invented it. Yes, okay, I've got that, I bought that. I know from my personal experience with electronics that I can wirelessly enable my pan tilt head. So it's something I'm doing, and it will help me out, but it might help you out also. So I'll put my circuit board to one side, sorry. A bit bunged up today. I haven't got a cold, but it's just that time of year, so my nose is a bit bunged up, sinuses are knackered, so please excuse my muzzly old chatty voice. Right, Another tip as well, if you're marking and you wanting to drill holes, whether it's in ABS plastic, stainless steel, mild steel, wood, use an automatic center punch, and what that will do, it will kind of save your drill bit from walking around in circles before you drill the hole, and you end up with a load of scratches around the area where you wish to drill a hole. But if you use an automatic center punch and you mark the box, but the good tip is buy an automatic center punch that works like that, because I bought a few and they don't work. So put it in where you want to drill a hole, press it down, and it will give you a dimple hole exactly in the center. Then you can, with an HSS high-speed steel drill bit, even in plastic, I wouldn't recommend using a wood bit in plastic because they do break off the ends. And another tip, if you are drilling into like ABS plastic or polypropylene like this, don't go too quick, because the problem you'll have is then you'll go too quick through the hole, and then once you've gone through the hole, your drill bit will hit the face of the enclosure, and then you'll end up with a nasty old mark where your drills hit it. So if you're making something that you wish to sell, maybe you're an electronics creator, you make PCB circuit boards or projects, you sell them on eBay or Etsy, for example, you don't want scratches. So take your time. Always as well, get yourself a notepad and draw out and plan your build. Also, if you're not sure with electronics, like I'm doing, if you're not sure what you're doing, you can always practice, and I'll just bring something into shot that may be of help. I buy an absolute stack of these electronics kits because I use a lot of components, because I fix and service sound and lighting equipment for a friend of mine that's got a marquee business. So in here you've got resistors, etc. But also you can buy what are called breadboards or prototyping boards. So a breadboard is a plastic board with lots of single copper connectors inside, and when you get these what are called header pins, what you can do, you can get your board, you can push into your breadboard like so, and then you can run wiring off in parallel diagonal lines, and then tie it into the red rail, which is a positive, the negative, which is your common rail, and you can test and prototype your design before making final connections and soldering. So that's very helpful using a breadboard. And also there's lots and lots of components in here. I've got resistors, diodes, LEDs, switches. It's just an affordable way of buying bulk components, but you can never really have too much kit. If you're serious about electronics and you do a lot of projects and make a lot of things, it's invaluable to have. Right, I've now got a stepped drill bit. This is a step cutter. So if you're wanting to drill holes or enlarge holes, I wouldn't use a hole saw because they're too big, they vibrate, they rattle around. Do not use a wooden flat bit in plastic to drill holes, because it literally will just walk around and make a massive great hole and knacker up and damage everything you're doing. Also, it's good if you're not sure on sizes, just bear with me 1 second. Right, so if you're doing an electronics project and you want to work out a size of something, maybe you're wanting to know how big to drill that hole, and you can also offer that up against the drill bit to see how big it is. I've had this for absolutely years, and even though I've got a great eye for sizing things up, this is made by Silverline. It's a stainless steel plate, laser etched markings, and it has holes. So with this rubber gland, it's a game of snap really. You don't want a really too loose a hole, so that's 7.5 millimeters. I can fit it through that hole, and it's a little bit tight, and it's 7.5. So I'm going to drill a 7mm drill bit, because 7mm hole, because it is really tight, but I've also got to think about the wire, which may expand that as well. So that's a drill size guide. That's in metric or bananas, or if you're in the US, you can actually buy those in imperial. Poor people using imperial. Or you can get like a dial gauge, electronic calipers like these. I've got it set to millimeters. Put that into the caliper, give it a little squeeze, and it will come up saying 7mm. So there's two forms of things. This is really handy if you're working with fasteners, nuts and bolts, because you can just quickly put a bolt in there and you can give yourself a very clear indication of what size and diameter something is. So like a standard pencil is 8mm. But if you're hanging along for the video, I'm really grateful of your support. To those of you that are subscribed and supporting my channel, have been loyal, I really appreciate all of you. Just recently got over 1,000 subscribers, which I'm extremely grateful for. When I started my channel, I think it was 2009, I was just uploading videos of things that interested me. I've never thought solely about doing kind of like using YouTube just to make money. And anyone that wants to set up a YouTube channel, I'll be honest with you, unless you've got a real niche, you might gain traction and subscribers, 20,000-30,000 subscribers extremely quickly. But for me, it's taken me, well, God knows, 9 years or so. But I do it because I want to do it and I want to enjoy it. But recently getting over that landmark of 1,000 subscribers has been brilliant. I'm not saying that on a financial reward standpoint, because at this very time, still, I've not seen a penny go into my bank. So what we're going to do now is we're going to ream that hole out. So just go and get a reamer. Right, just going to clean my hole. Sounds a bit rude, doesn't it? It's always very good to go very slowly when marking off holes. You don't want to drill too fast because you'll oversize your hole. So even if you make many attempts at drilling a hole, it's better to drill something 8 or 9 times and work your way to your overall size than buzz straight in with a massive drill bit and completely undo all of the work that you've done. Just finding a hole saw to work as a reamer, because all of my metric drill bits are all they're all even sizes, so finding a drill bit that's just shy of 7mm is proving somewhat of an issue. So let's just get my deburring tool in here. Right, that's brilliant. Right, so I've now finished my marking out, my drilling. I can remove my masking tape. And just for demonstration, that was the hole that I went through, and I've got a perfectly clean hole that isn't damaged and oversized. Blow out all the bits of material from the hole. Insert my strain relief shroud or grommet. If you're working on larger projects, you can use cable glands, which are a compression fitting, which ensure that your hole will have some IP protection to waterproof it. But IP is ingress protection. So I've got that there now, so I've got a bit of a strain relief on my wire, and then what I'll do in the project is I'll just affix that with some hot glue, which I'll go and get the glue gun now. Right, one glue gun, we'll let that heat up. Right, so I'll now move on to my wiring side of things. I'll just get my cable. So I purchased a series of 7-pin DIN plugs on Amazon, and I've just cut one up just so I've got a very short lead for this particular project. I don't want it too long, it's just going to be long enough so that I can have it affixed on the side of the actual panhead tilt box with some velcro. So it hasn't got to be long because this will go onto the device itself, so this will move around remotely with the head, so there isn't any wiring to tangle, because you've got to remember this unit will do 360 degrees. And that was the problem using the wired controllers. You'd end up getting to a point where all your wiring tangles up because it was tangled around the neck of your tripod, for example. So being that it's fully wirelessly remote controlled, I won't get any problems with tangled wires. And if you're certain cameras or certain video cameras, you can actually use remote controls with them if they come with a remote control. My DSLR, my mirrorless Sony A7 III, actually has a remote control that I purchased for it, and I can actually focus the camera through the remote control, which is brilliant, which means I can then run this complete head fully wirelessly. I can go up, down, I can zoom the camera in and out, and then I can allow the autofocus to work as well, which will really add a benefit to the overall project. But this is brilliant. Like I say, you can put a GoPro on here. You can buy similar kind of devices nowadays on Amazon. They're extremely cheap, but they don't really hold much weight, where this pan tilt head will hold 2 kilos worth of camera and lens combination. So putting a GoPro on there, or a DSLR, a Canon camera or something like that, Pentax, you haven't really got any weight in it, so it doesn't really matter. Right, just taking off some wiring, the sheathing from the actual plug, which is here. All I'm going to do now, so always remember, if you're working with an enclosure or you're working with any kind of like cable management, where you're putting a wire through a hole or you're using a wiring connector, you always make sure that you actually put the outer casing or a grommet or a shroud or a locking nut over the wire first, because once you've made all your connections inside your enclosure, you'll then struggle, and then you realise that you'll have to cut the wiring off or unsolder the whole of your project just to put a nut or something on the other end of the wiring. So we're going to put that through our box like so, pull it all the way out the way, and then we've got that end we can work with, and we're safe in the knowledge knowing that we've put our wiring in first. So heat shrink, extremely good to have lots of heat shrink. Cable glands, these are what I was talking about, compression glands, brilliant for larger projects where you'll need a bigger wiring, and you can actually lock that, and you can then work with your same IP protection. What I will say as a tip, actually, while I'm thinking about it, these boxes, these enclosures that I purchased on Amazon, I purchased these because I knew what I was looking for and I knew what I wanted. However, these particular boxes are sold from multiple suppliers through Amazon, and a lot of them, I made the stupid mistake of calling them waterproof enclosures. Let me just categorically say now, these are not waterproof. They do not have any kind of sealing material, O-ring gasket material, soft foam rubber, or silicone gaskets, or kind of ring, like a big O-rings that sit in them. So they are not waterproof. Please be on your guard that if you're wanting a box for waterproof use, whether it's outdoor Christmas lights, ham radio balms, if you're not sure, leave a comment and I will point you and signpost you to the correct application box that you will need for your project. Because if you get it wrong, you know, playing with electricity isn't good. It's dangerous. Even with low voltage circuits, you're going to fry something, break something, and all your hard work has been undone very quickly. So for my box, I only need a short amount of actual wire in the box. Good quality pair of sharp side cutters are a must when working with wiring and electronics. Right, we're going to strip our wire. So I've got some other wire strippers. I've had these for years, but I'd never actually used them until recently. I got them out of the box and started using them, and oh, absolutely lovely. So you put your wire in, you can select the size of the actual insulation that you want to remove, put your wire in, gently pull it, and it very neatly removes the insulation. Not brilliant on smaller diameter. Whoopsie daisy. Apologise for that. My glue gun fell over and I knocked the camera tripod. But these aren't the best for extremely small diameter conductors like these, but they do. But there are many types of wire strippers out there, but the best thing to do is not use your teeth. Don't use a pair of scissors. Use the correct tool for the job. So I need to tighten this up a bit because the gripping force isn't very good. One second. So the old saying, 7 P's, prior planning and preparation prevents piss poor performance. So I reverted to my old school American wire strippers that I've had for many years, and these work, but they are manual and they work the treat. It isn't the best polished video. Keep knocking the camera. It's only because I need to get this project done because I've got other uses for it. I thought I'll let you come along for the ride as well. So I thought I'd film it while I'm doing it. So if you're really bored, you can watch me do this. You can watch another one of my videos, or whatever takes your fancy, really. Right, once my wires have been stripped off, what I'm going to do next, I'm literally going to twist the ends together just so they're not all frayed everywhere. Split the end of my finger open as well because of the weather, working outdoors all the time with water. It's not very good for your skin, funnily enough. It dries your skin out and your fingers get hard and they crack. I guess that's just an age thing, really, us old people get. Right, I'm going to solder those and tin those ends. Out comes the soldering iron. I will unplug the glue gun for now because I don't actually need it at this minute in time. Get my soldering iron stand out, which I've had since I was at school. Brilliant, stops you burning all your work, stops you burning the power cable for your soldering iron, and also has a damp sponge pad which allows you to dip your tip and to clean any solder or flux residue off your tip. Third hands, these are really good if you're wanting to support wiring, electronics, just to get things into an area where it's best working for you like that. I can clamp the wire in there, as so. I'll move the camera for you, and my wire's clamped. There's countless ways in how to solder. I'm not here to teach anybody how to solder. I've been soldering since I was about 8 years of age. I do it my way. You can do it your way. I'm using a slightly oversized solder, 1.5mm is the closest one I could grab at the box. Another tip as well, an invaluable tip for anyone in today's age, with the increased talk about a so-called climate emergency, etc., and everyone trying to be more environmentally friendly and sustainable and planet loving and all that lot. The best solder you can buy is the old school style of solder, 60/40 lead tin. So it's got lead in it, it's got tin in there. This is Weller, an extremely well popular brand that's been around for many years, extremely established, made in Germany, and it's got multi-core flux in there as well. If you buy newer, cheaper solders, they've got more like an aluminium alloy in them, and they don't really fuse because they haven't got like proper flux and they haven't got tin or lead in them. And the problem is it's more like liquid aluminium, and you'll end up with a lot of dry joints, and it's not really the best. So buy lead tin solder. I do recommend it, especially if you're soldering lots. I've said in many of my videos previously that I've noticed nowadays with the generations of people, with the introduction of electronics, mobile phones, which came into service really about 1995. Now even like 7, 8, 9, 10, 11-year-old kids have got mobile phones. So people don't really anymore have hobbies. You know, their hobby might be, I'm going to make a TikTok video of me dancing like an absolute pleb. Which you're not really doing anything productive with that. But electronics, I love electronics. I do a lot of electronics. Another admission, I've got 2 sewing machines. I do an awful lot of sewing. I repair things. I repaired my gazebo from the summer. I've made like covers, bag covers. I've made camera covers. All sorts of things you can make. It's amazing. You know, get in there, get soldering. You'll learn a lot. Right, so my pin out. So when they say pin out, that's basically a map of the pins that you're going to be using and the wiring that you're using. So what we have here, which I'll add into the video at some point, is a pin out, which is basically a map, and it shows me an identical picture of my socket with the wiring, and it tells me what my functions are. So what I'm going to do now is get a pencil and a notepad. So I'm going to count these. So there's 7. 1, 2, 3, 4, 5, 6, 7. I'm not using speed, so I only need 6 pins. So we go 1, 2, 3, 4, 5, 6. So what we'll do, I'll write numbers 1 to 7. 1, 2, 3, 4, 5, 6, 7. I will cross out pin 1 and write not using. So then pin 2 will be left. Pin 3 will be down. Pin 4, 1, 2, 3 will be 5 volts. Pin 5 will be up. Next one is right, which is pin 6. and then pin 7 is ground, or negative in this point, because we're not using any metal chassis, so we've only got ground. So what we're going to do now is, because what I've done is I cut the plug off something else, so I now need to remember which pin format and where these pins go. So the easier way to do that is with a multimeter. With your multimeter, you can either use ohms, continuity. So my multimeter should give me an audio beep function. When I short those out, it'll give me a beep, and the resistance in these leads is about 1.3 ohms in that. So what I need to do now, I need to work out which pin is left. So that will be pin 2. So I can, with my meter, and it makes it a bit more exciting now because I need more hands. So I bring in the third hand, I'll move that out of shot. So I'm now with my plug and my multimeter, I'm trying to hold it with one hand on the ground pin, which is pin 7, which is the bottom right hand corner of the pin in the circle. Right, that's in there. So just double check. So pin 7 is that one there. Which is my red wire. Red. My next pin I'm going to do is pin 6, which is my right hand function. So what we're going to do this time is try to hold it still on the pin that I need, but not the other pin beside it. Unless you've got a socket and you can put the plug into that socket, or you're making your own plug from scratch and soldering it, it's a bit easier to identify your pins. But when you're using a plug that you've cut off something else, it makes it a little bit harder. So we're looking for right hand function. Just to double check, I believe it's the yellow wire, yellow conductor. Yes, it is. Right, the next pin function is our up function, which is the next one up, which would be in reverse. So we've got 1, 2, 3, that pin there is our up function. Which is our blue wire. Our next one is our 5-volt signal, which is our absolute top pin. So 5 volts, this will make you laugh. If you know anything about electronics, just double check before I say what I'm going to say. Right, so our top pin So just one other thing, with a DIN plug, which I'll insert a picture on the screen now, there is so the plug that I'm working on is a 7-pin plug, so the symmetry of the plug, it's like a half moon really, and there will be a dimple at the bottom of the plug, like it's a hole or an indent, which will give you an identifier that that is the bottom of the pin. So when you'll see a diagram of the circuit, you'll be able to see the actual orientation of the plug. So our 5 volts or plus will be on a white wire. We're looking for our down function now, which is the next one over from the top. Black. Just double check. It's hard because I really can't show you what I'm doing, but it's unfortunately using a GoPro you can't zoom. But what I'm doing is trying to hold a wire against a pin against a rather large oversized test probe, but without touching any other pins. So we use our black pin as our down function, and one left by process of elimination can only be one out of 2 or 3 conductors which are left, which is our purple pin for our left hand function. Purple. So I'm not using all of the pins because I'm not using, in this plug there are 7 conductors. I'm only using 6 because I'm not using the speed function with the speed, so I can speed the thing up. So I am using our red wire, I'm using our yellow wire for those that are heavily into electronics, or my blue conductor. We're using black and white, so just double check. So we're using red, we're using yellow, we're using blue, we're using white, we're using black, we're using purple. So the green wire is, we're not using that. So what we'll do, just simply remove that. Right, so now we know which of our pins we are using. What I'll try to do now is remove all of my clutter that I've got in the way. So my notepad, I've got all of my pins, colours and their functions written down, so that will give me a wiring map or a plan which will help me and tell me what I'm doing. So what I'm doing now is we're going to plug our wire into our pan head. I'm going to now switch the pan head on, green LED, and we put it in manual mode. I've got that set up now, like so it's straight with the camera. So what I want to do now is I want to rotate that to the left. So what I'm going to need is I'm going to use my 5 volt signal, which is on my white wire, and I also need then my purple wire, and touch the two together. Brilliant. We've got our ground as well. That works. Lovely. So on the bottom of this, the bottom actually moves. Brilliant. Right, I'm just going to make some alterations. I'll be back shortly. Welcome back. Okay, I had to take a break to just get things working. This project is new to me. However, remote controls, wireless transmission is something I'm pretty well versed in, something I'm very used to. But this project was confusing me a little bit because I'm dealing with a 4-channel remote control in a very compact, small form factor, and the wiring was getting a bit tricky. Plus, I'm extremely tired. I'm not going to make excuses. I'm tired. It's been a long day for me. But I wanted to make a video and try to share this with others because these CamRanger, Bescor, Hague, pan tilt motor heads are popping up on eBay quite a lot recently, and people aren't using them. So if you're into video production, blogging, streaming, etc., product reviews, they might be really handy for you. Or whether you want to go and film your child, your friends, your colleagues to playing football, rugby, put it up on a tripod, sit there with a remote control, you'll get a more fluid panning motion than you would doing it by hand, and also sometimes better than a tripod because it's remote and it's electronic. So the remote control receiver is extremely small. I had a couple of breadboards, which are the white boards that you see in front of the camera. Had a few of them from years ago, and I mean since I was like 10, 11 years of age. They were extremely worn out. The pins weren't making contact, so I threw it away and unwrapped a new one that I had in storage. So the project and this remote control is completely new to me. I hadn't even searched the internet because I don't think anyone else has ever attempted it, because these devices have been out for many years. You can pick them up on eBay, 20, 40, 60 pounds, depending on the condition of them. They're extremely easy to use, very versatile, and recommend getting one if you're into streaming, etc. But so what I've done, I've got the remote control in front of me. I've got my receiver set up on my breadboard. I've used my pin out wiring, which is here. So I've got my white wire, which is my plus 5 volts, my yellow wire, which is my left, my black wire, which is my up movement, my green wire, which is my right movement, my blue wire, which is my down, and my red wire. This is stupid. The red wire is ground or negative. So plus is black and red is minus, basically. I stole that from LR Time. So my remote control's here. I've got the board wired up to prototype this design, so I can finally now write down which pins are on this circuit board to where the pins of the wiring to the controller again. So my A button is my left. My B button is my right. My C button is my up, and my D button is down. So I'll just take off the tripod. I was getting a lot of strobing, linear strobing, because of my LED lights. So because I was using my camera for something else a while ago, I changed the frame rate on there. So 50 frames per second works with 50 hertz electric in the UK here. So I'll take you in for a closer view. So A, it turns left. B, it turns right. C, up. D, down. So what I'll do now, my GoPro has got Hyper Smooth enabled, so I'm just gonna try to do this as steadily as I can for you. So this video is completely natural, organic. It's not some polished production. That's not what I'm about. I'm about realism and try to show someone how to do something my way, in my terms. So my camera now, you're fixed up upon the top of this device. So A, my camera pans to the left. If I press B, the camera pans to the right. If I press C, the camera comes up. If I press D, the camera goes down. So what I'll do now is I'll write down the on the circuit board there's writing beside each pin, not numbers, just random letters. So I'll write those down onto my piece of paper, and then I can make my final solder connections to the board, and I'll bring you back shortly after that. Okay, you join me back at the finished project after some testing and some connections. So what we have, the wireless receiver circuit board is a Yankee Kilo 04 YK04. It's a 315 megahertz 4-channel remote control. What I'll do within the very long description of this video, I will mark down the model number of the receiver board. I will also attach a link to the UK seller where I purchased this particular board. So if you're outside of the UK, the link may not work for you, but you can find alternatives. But what I'm trying to do is connect this board with its model number. Then I can specifically give you the plan for the actual wiring orientation to control. So the color coding will not work for you. However, the circuit board numbering along with its functions I can list, and then I can tie that whole thing together so you'll have an idea of where you're going if you wanted to replicate this for your CamRanger, your Bescor, or your Hague PTZ or pan tilt head. What I've got is my little black enclosure. Everything's all neatly wired up, soldered, heat shrink, standard procedure for myself. That box snaps shut. I'm going to put some Velcro onto there, and then that will sit nicely on the side of the box like so, and then it'll be completely wirelessly independent, and I can do what I like with it. So I get my remote control, but a nice little fun easy project, pretty much straightforward. You know, all you need is a good eye for detail, an ability to solder. There are some very fine connections, but it's basically just like a little wireless bar. It fits on there, and I think it complements it quite nicely to give it the remote control capability. But it's a long video. I apologise for me waffling in some areas. That's part and policy of dyslexia, I guess, and also depression, mental health and anxiety. It's been a long day. I've got this done. However, I'm happier now. I've finished the project. I just wanted to share it with a wider audience so maybe others can learn from it, others can benefit from it. But if you like the video, please give it a thumbs up. Please leave a comment. Check out the video description in full for all the details on this project build. Please subscribe to my channel and help it grow. I really appreciate all of you for watching, wherever you are in the world. Thank you very much. But yeah, like, share, comment, subscribe, press the bell icon for notifications when new videos are published, and stay tuned for more content. Many thanks. Big love.